Hello everyone. In this video we're going to be solving an equation with the floor value. Please comment, like and subscribe. I really appreciate your support. So let's go ahead and get started. So we do have x minus the floor value of x is equal to 1 over x. So a couple of things to note here about the domain of this function before we start solving it, because that's going to be playing an important role at the end. Okay, so first of all, notice that the floor value of any x is going to be less than or equal to x. So we know that the floor value of x is always less than or equal to x. We know that, right? Because the floor value is basically the greatest integer function. So if you have something like 3.5, it's basically going to take away the decimal part and it's going to give you the greatest integer that is less than or equal to the number, which is going to be 3 in this case, right? But if you have a negative number, that's a different story, because again, the floor value needs to be less than or equal to the number itself. So in this case, it's going to be a negative 4. So basically, the floor value of x is always less than or equal to x, which means that this on the left-hand side, we do have a positive quantity, which means that on the right-hand side, we also have a positive quantity, which means 1 over x is actually non-negative. Since x cannot equal 0, we can safely say that 1 over x needs to be greater than 0, or x is greater than 0. Since x does not equal 0, we can safely say that x must be positive. So let's take that into consideration as we solve this problem. Now, how do we solve this problem? Well, one of the things we can do, which is kind of fairly nice, is let's isolate the floor value of x here. So we can write it as the floor value of x equals, if you go ahead and put it on the right-hand side and switch sides like this, you're going to get the following equation. So the floor value of x is going to equal x minus 1 over x, right? And then what you're going to do is, most of the floor value problems can be solved with substitution. So that's what I'm going to do here. Let me go ahead and call this n. All right. So by calling the floor value of x equal to n, we get an inequality. Since the floor value of x is the greatest integer function, this indicates or implies that x must be between n and n plus 1, in which case n is an integer, okay? N is an integer, x needs to be in that interval. So we're going to check that as well. Cool. Now, how do we proceed from this point on, right? Well, we do have like an equation here, which we can use. Let's go ahead and write that down. So we have, I'm probably going to switch over here. Okay, x minus 1 over x is equal to n. Let's go ahead and multiply both sides by x. And obviously, x does not equal 0. We know that, right? So it's okay to multiply both sides by x. That's going to give us x squared minus 1 equals nx. A lot of people try to make common denominators. You don't really need to do that. Just multiply both sides by the common denominator, and you'll get a nice expression. So let's put everything on the same side. X squared minus nx minus 1 is equal to 0. So what do we get? N is an integer, and this is a quadratic equation. So how do you solve this quadratic equation? Since we don't know what n is, and n could be any integer, right? Well, we can just use the quadratic formula, right? I mean, since this doesn't seem to be factorable, so we can just go ahead and use the quadratic formula. Let's use it. X equals negative b, which is n, plus minus the square root of b squared, in this case it will be n squared, minus 4ac. A is 1, c is negative 1, so their product is going to be positive 4, and then we're going to get this, and all divided by 2. Awesome. So we basically got the x value, but it's not very specific. We're going to, kind of talk about the details in a little bit. But before that, I want you to realize one thing here. We actually started with some requirements, such as x needs to be greater than 0, right? And n is an integer. So let's go ahead and copy those here. X is positive, n is an integer. So what's that supposed to mean? Well, Here's something that I want you to realize. First of all, let me go ahead and split these into two equations because I need to look at them separately. Okay. There's going to be two solutions like x1 and x2. N minus the square root of n squared plus 4 divided by 2. Awesome. Now, take a look at each one of these separately. If you look at x1, is x positive here? Well, n is an integer. If n is a positive integer, we're good. If n is a negative integer, we have to compare these two quantities. Well, obviously, the square root of n squared plus 4 is greater than the square root of n squared, which is actually equal to n, right? So in this case, if n is a positive integer, this is going to work. But if n is a negative integer, if you think about it, this is always going to be a positive quantity, right? And you subtract add a negative quantity, which is actually less than that. So this is always going to be positive. So the first one actually passes the test. But let's take a look at the second one. So we have a problem with the second one because notice that the square root of n squared plus 4 is greater than n, right? So this difference is going to be negative. So we're not going to be able to take the solution. We're going to reject it, okay? So we're going to go by the only solution that we have here, which is this one, right? So that's going to be the only acceptable x value, which is the solution to our equation. Now you may be saying like, okay, this is too generic, right? Well, it just means that this is true when n is an integer, okay? Now let's check if it's going to work for negative integers, okay? I'm just curious. Okay, so let's say we have something like, I don't know, how about -1? Let's keep it simple, right? Okay, what if n equals -1? If n equals -1, that doesn't look like -1 at all. So here we go. If n equals -1, then you're going to get -1 plus the square root of n squared, which is 1 plus 4. That's a 5 divided by 2. Now, as you can see here, this is a positive quantity, right? I mean, this is always going to be a positive quantity. Why? Because this absolute value of this expression is actually going to be always greater than that. So we don't have a problem with this. Everything looks good. And that's it. That's the solution where n is an integer. This is going to be the x values that satisfy our equation. And you can kind of test it out, like substitute some values. And then what you need to check is basically find this difference, x minus the floor value of x, right? And then from here, you should be getting 1 over x, which is going to be kind of like the reciprocal. Okay? Well, that's it for this video. Thank you for watching. I'd like to see you in the next video. Have a good one. Bye-bye.